Section 10.4, the hyperbola. A hyperbola is the collection of all points in a plane, the difference whose distances from two fixed points called the foci is a constant. Okay, so the idea here is, let's say I drew another line from here to here. I'm looking at this point right here. Then I drop this down right here. If you notice, if I kind of swing that around, okay, what you'll notice here is if I take this distance here and subtract it off, I get that amount left, that black amount down here. Okay, now if I do the same thing with the other distance that I just created, I would be eliminating all of this. So if you notice, these distances are going to be the same. So that's what they mean by a constant distance if I subtract it off. And when they subtract it off, they said the difference here. Okay, and that's what they mean. So no matter what line I drew, if I connected the dots to the foci to that point and swung that around, I would get that these distances would all end up being the same. That's really what's going on here. So it's those distances when I subtract them. Actually, those constants will be constant. Okay, so that's what we're dealing with here. Now we're going to actually get into some problems. I just wanted to give you kind of a heads up of where it's all coming from if you hear about the hyperbola. And now there's a lot going on here that we're going to talk about. So we have some different words. Well, foci is the same. So those are going to be these pieces here, F1 and F2. Those are the foci, or foci, excuse me. And we're also going to have this transverse axis. Okay, now that's going to be the axis where the focus, or both the foci, and where the hyperbola crosses. Because notice they cross here and here. Okay, so that's where, that's going to be the transverse axis. In the ellipses, we called it a major axis. Here it's a transverse axis. Now here's the equation of this, or these hyperbolas in general. So here it is. And going through some algebra, just like we did for the ellipses, we can come to this result. I'm not going to go through that just for the sake of time, mine and yours. But anyways, take a look at this. This is a horizontal hyperbola, which means it opens up left and right, kind of like we dealt with the parabolas, and also kind of what we dealt with the ellipses. So the idea here is, notice my x squared is positive. And that's an indicator that's going to tell me it's going to have the transverse axis across in the x direction. So that's one thing to kind of make a note of as you see that. And the variable that has the negative, that's where we're going to have where our graph doesn't touch. Now again, we're going to be doing shifts over, so we may touch the y-axis, we might touch the x-axis with the different variations of this, just because we can move things over, but just kind of keep that in mind. This is the direction we're going to be going in if our x squared is positive, and we're going to go in this direction from left to right. And just keep that in mind. Now there's another component here that changes. You guys remember this equation here? This equation is different from the other one because the other one was b squared equals a squared minus c squared. That was the one for the ellipses. So that changes a little bit. And also the way we think about it. Remember, for the ellipses, this was the largest one, that was the smallest number, and the smallest distance from the center to the edge, or I should say, to the graph. Okay, so those were things we dealt with in the past. So this changes a little bit. This here is going to be the number of the variable that's negative. And this one here is going to be under the variable that's positive. So that's one way to look at it. And they did switch around. So just kind of keep that in mind as we go through these. That's the way it's going to be. So again, this one here is going to be under the variable that's positive, and this b here is going to be the one underneath the negative. So that's how we're going to think of these from now on. Now there's one more component that we have to deal with here, and that's the asymptotes. So we have some asymptotes we're going to deal with here too. Now here's the side. So notice how this looks here. So this is saying here, our asymptotes of an hyperbola are going to be b over a times x, and then negative b over a times x. And these are y equals simply because they're lines. So how this works is it's always change in y over change in x. That's the idea here. So when I look at this, notice the b is under the y. So that's going to be on top. And the a is under the x, so that's going to be on the bottom. And that's generally how those work for either hyperbolas. Now they changed the variables around, which I think is okay, just for the sake of their formulas. But as we get into these, if we can just hang on to those general principles. The first one being this a is the positive, underneath the positive, and the b is underneath the negative. And then for these asymptotes, the top is always under the y, the constant under the y, and the bottom here is always the one under the x. So those are just components for us to think about as we go through these. So that's the basic layout here. So essentially what's happening here is I have these asymptotes here and here, and that's what we're dealing with down here. So those are just things to keep in mind. So that's about it. And this is going to be enough information for us to graph these. So let's take a look at this one. Here's the other side of it. So here's the equation for the hyperbolas that are vertical. Okay, so notice here, here's the foci now. Now those are on the y-axis or up above each other. And then the vertices are here. Oh, I forgot to mention the vertices on the previous one. Don't forget about your vertices. That's what these are here. So you got the vertices here. Definitely label all those. But anyways, going back to this one here, notice the setup for this one now. Okay, this one says, hey, remember what I said here. The positive one goes here, and the negative one goes here. Okay, and that's kind of what you notice there. So if you see this here, that's going to be the positive one. That's going to be the negative one. And I mean positive and negative here, that's positive in front of that. Since there's nothing there, and there's negative in front of that one. That's what I mean by positive and negative. And actually they switch around a little bit too, because it's before, remember, it was the a squared minus the c squared. And that changed too. But that's okay. That is what it is. So now the other thing is, let's talk about the equations here of the asymptotes. So here are the equations for the hyperbolas for the asymptotes. Okay, so here we go. So notice this. This is my y over x. Remember I told you about that? And that doesn't change here. So here's my y. That's my a squared now. And then my b is underneath my x. So that doesn't really change here. So I can always think about the number under the y being on top of this ratio over the constant underneath the x on the bottom. So that's a really nice thing that I can take from all of these. And here's a nice little picture that we can see with the hyperbolas in it. And this gives you a reason why the equations are the way they are. So take a look at this. Here it is. So now looking at this, notice what they did here. They said, okay, this is 0b up here and 0 negative b down here. And then this is my and this right here is going to be my a right here. So then when I think about this, I go up b and over a. So you can kind of see how that actually works out. That change in y over change in x. And that's always going to be the case here. And it doesn't matter if I flip it around and I talk about these other ones here. I'm still going to get this same box in here. And I'm still going to get these same lines running this way and this way. Just so you guys know, it doesn't change. Now let's do some problems.